if V and W are two vector spaces and T is a linear map between V to W, from V to W, then the linear map T is 1 to 1 if and only if the null of the linear transformation is only the 0 vector in V. That means if T is 1 to 1, then only the vector from V that maps to 0 vector in W is the 0 vector. And to prove that, so we need to prove both direction. So suppose T is 1 to 1, suppose T is 1 to 1, and we want to prove that the null of T is the 0 vector. Okay. So if X element of null of T, so X is a vector in null of T, then by the definition of null of T, T of X is 0 W. That means it will map to 0 vector in W. Okay. And we know that 0 vector always map to 0 vector in W. That means 0 vector from V always map to 0 vector in W. So we can also write this one as T of 0 V, because T of 0 V is always mapped to 0 W. Okay. Now since the map T is 1 to 1, since T is 1 to 1, so since T is 1 to 1, so T of X, this one equals to that one, it means X equals to 0 V. Okay. That means only the vector that maps to 0 W, 0 vector in W, is 0 vector in V. So X is the 0 vector. So that means 0 vector element of null of T, that is, hence null of T is the 0 vector in V. So we prove one direction. Now we will prove the opposite direction. So this direction, suppose the null of T is the 0 vector, and we want to prove that the linear transformation is 1 to 1. Now if T of X equals to T of Y, then so this is in W, right? T of X, that means it maps to W. This is also T of Y. So if those are same vector, then their difference would be T of X minus T Y. If they are same vector in W, so their difference would be 0 vector in W. So 0 W. Now since T is linear, so we can write this one, T of X minus Y equals to 0 W. Okay. So since null of T is 0 vector, 0 V, so that means X minus Y is 0 V. That means the difference of two vectors in V is 0 V. That means they are same. So we can write X equals to Y. Now if T of X equals to Ty implies X equals to Y, that means that linear transformation is 1 to 1. That is, by the definition of 1 to 1 map, T is 1 to 1. So this completes the proof.